So before we took our test last week, we talked about the Earth's crust. Do you guys remember specifically what we said about the Earth's crust? It's very thin, it's where we live, yes. We talked about tectonic plate theories. Anybody remember what tectonic plate theory is all about? So the crust is not one consistent piece. It's broken up into many smaller pieces. We call those pieces tectonic plates. So that's basically what tectonic plate theory is in a nutshell, is that the crust is broken up into many moving pieces. So the Earth is not, it does not stay still. Each piece moves independently of each other. And we talked about that this is probably due to mantle convection, this idea that the mantle is circulating heat currents. Again, there's that circulating heat, that's convection, that's making these plates move like boats on a river. Really, really big boats. And yeah, so here's kind of a map. If we could take an X-ray of the Earth and see where these boundaries were, this is approximately where they are, to the best of our knowledge. They cut through oceans, sometimes they cut through land, and we'll look at a few examples of that today. So what we're talking about today are called plate boundaries. So plate boundaries are these black lines where one or more plates meet each other. So these boundaries are important because, like I said, these plates don't move in the same direction. Sometimes these plates are coming towards each other, sometimes they're moving away, sometimes they rub up against each other. Whatever the case, they have some sort of consequence, or they have some kind of result. Have any of you guys been in my geology class before? I mean, sometimes people are in geology and then they go to earth science. Usually it's the other way around. Okay, so you guys have not talked about this before. Cool. So the first type of plate boundary we're going to talk about is a divergent plate boundary. This is where two plates are moving away from each other. I'm going to show you guys a demonstration here. So what I have here is I have a plate full of peanut butter with a couple crackers on top. So my peanut butter is going to be my mantle. And if my peanut butter is my mantle, what does that make the crackers? Yeah, plates. So these are tectonic plates or pieces of the Earth's crust. So in a divergent plate boundary, what happens is that the Earth's crust moves away from each other. When that happens is that now we have this mantle that's exposed. And that exposed mantle is hot, so it's not just going to stay there. So what happens is that mantle will rise, and eventually it will cool down and become new crust. So whenever we have mantle material rise, usually that happens in the form of volcanoes. So one plate will move away from another plate, and mantle will rise in the form of lava. Eventually that lava will cool down, and when it cools down, it becomes new crust. So what used to be mantle is now called crust. Basically, whatever is on the top of the Earth, we call that crust, whether it used to be in the mantle or the core or whatever. The most popular example of a divergent boundary is called the Mid-Atlantic Ridge. So in the middle of the Atlantic Ocean, you have the North American plate and South American plate on one side, African plate and Eurasian plate on the other side, and these plates are all moving away from each other. And it's creating this huge ridge in the center of the Earth called the Mid-Atlantic Ridge. And if you look at the top of this map up here, it actually cuts through Iceland. So this bottom picture right there, that's a picture of the Mid-Atlantic Ridge in Iceland. And you can actually pay to go scuba diving and be between two continents. Okay. Oops. Okay, so questions about the divergent boundaries? So next type is called a convergent boundary. Okay, so this is divergent boundaries when plates move away. Convergent boundaries when plates move toward each other. So this is some kind of collision between two plates. So going back to my little food demonstration here. So if I have two plates move toward each other, see if I can get this to happen right. What will often happen is that not all plates are made equally, so usually one plate will move on top of the other. So usually an ocean plate will go underneath a continental plate. Remember I talked to you a long time ago, there are two types of crust, continental crust and oceanic crust. So the continental crust is usually lighter, oceanic is usually heavier, which ends up on bottom. So this actually gets recycled back into the mantle. Let me see if I have a good picture of that. Yeah, so that ocean crust will get recycled into the mantle, right? It could be continental crust. But now that continental crust is pushed way up. And so usually when you have two plates meet each other head on, one plate will go on top of the other and raise, and that's how most mountains are formed, is when one plate is pushed up, and so it kind of gets scrunched and pushed up at the same time and make a mountain. Yep. That's how most mountain ranges are created. A really good example of this is the Himalayas. That's the mountain range where Mount Everest can be found, which is now a very popular tourist attraction. What makes Mount Everest so popular? Do you guys know? Not say what? Yeah. So Mount Everest is the tallest mountain above sea level. It's basically the highest point on the earth you can go. And that is, so it can be found in the Himalayas. And the Himalayas are found between India and China. It's called the Nepal or Tibet region. And so the theory is that a long, long time ago, when I say a long time ago, I mean millions of years ago, India used to be its own island, but it's its own tectonic plate, so it moved up toward the Eurasian plate and is currently colliding with the Eurasian plate. So if you ever hear in the news that there was like a 7.0 or 6.0 earthquake in India, that's because there's this plate boundary where two plates are colliding, and when two plates collide, it's not going to be like a little bump. It's going to be a very big shaking of the earth. And we'll talk about earthquakes tomorrow. We'll talk about that. But anyway, that's what's creating that Himalayan mountain range, is that folding of the earth is making these really tall mountains. That's a good question. I don't know the exact height. Yeah, I don't know the exact height. Any questions about convergent boundaries? And by the way, this is like the top of the slide says example of CC convergence. That means an example of continent-continent convergence. There's also ocean-ocean convergence. There's lots of examples. I'm not going to go over every single one of them, but there's lots of different situations that the earth can find itself in. Last kind of boundary is a transform boundary. Oh, you guys can see what I'm doing. So transform boundary is when plates aren't moving toward each other, they're not moving away each other, instead like they kind of just rub up against each other. And what happens is that if they rub up against each other, that's kind of a little dramatic. They don't actually break that fast. But transform boundaries are known for their very strong earthquakes. So when two plates rub up against each other, it's not just a simple sliding past each other. Because my crackers are really smooth, right? They have straight edges. Well, tectonic plates don't have smooth edges. They're like rocks. They're really rough on both sides. And so if two big rocks are trying to slide past each other, they're going to get caught and they're going to get stuck. And all that pressure of the earth moving is going to make them slide past each other. When rocks break, when all that pressure releases, it's going to make a very big earthquake. That picture in the bottom right, that's the San Andreas Fault. And you can see that those are just lots of rugged hills. That's just the result of the earth rubbing up against each other. And yeah, so that's where the San Andreas Fault is on a map. It's in California. And I have some better pictures. Here we go. And so again, when two plates slide past each other, look at this bottom picture on the right. You can just see that the road becomes disjointed. It's just kind of, because again, the land is trying to move past itself. You can see the same thing here in the top left, where that river has just kind of like shifted. And like on the bottom left here, there's that curve that has come off of the, just kind of slip past itself. So that's a transform boundary. So those are tectonic plate boundaries. So if you guys haven't done your paraphrase from last week yet, hopefully that kind of gives you an idea of what tectonic plates can do in action. Did you guys have any questions about anything I showed you? I just explained it so well, I guess, huh? Which plate boundary is the strongest? Transform. Yeah, so they all produce earthquakes. Convergent and transform are known more for the earthquakes, but transform is definitely the strongest place to find earthquakes. You think so? Yeah. I think it's just because with transform boundaries, we say they move side by side, but since rocks are rugged and since they don't always move exactly side by side, I think it's because they just move in such unpredictable ways that it's just not a very smooth motion, which creates lots of bumps, lots of earthquakes. Yeah, the San Andreas Fault. Yeah, that's a transform boundary. Yeah, so let me go back to that slide. Yeah, so if you look at these blue arrows right here, the North American plate is going toward the southeast. Pacific plate is moving up toward the northwest. So you can see those are the motions. And like I said, see, even this boundary is not completely straight. And it goes straight through California and straight through Mexico. So, yeah. There is a way to detect when an earthquake's coming before it happens. Well, so yes, only because they know that they've known it before. Like, when people first moved there, they probably had no idea that this was an earthquake zone. But if you plot enough earthquakes, then yes, you'll eventually find out, oh, earthquakes are coming from this fault line. You have to have a few earthquakes happen before you know where the next one's going to happen, or could happen. Yes. Yeah, we're going to talk about that tomorrow. Yeah. That's called the New Madrid fault zone. It's not, if you guys will look at the map, let me go all the way back to the beginning. Missouri is in the middle of the North American plate. So but we still get earthquakes. You don't have to be next to a plate boundary to get earthquakes. It helps, but you don't need to be next to one. So tomorrow we'll talk about why Missouri gets earthquakes even though we're not close to a plate boundary. Lots of good questions. You guys have any others? All right, so again, let me just kind of go back here. Sure. Yeah, another good question. I was thinking about answering that. So usually volcanoes are not found on transform boundaries. And I'm going to go back to this slide to show that one, to show that answer. So this one's talking about divergent, but also on the left and right of this picture. So on the left here, that's convergent boundary, on the right, that's convergent boundary. So I talked about how divergent boundaries, the crust is exposing the mantle, and when the mantle rises, it usually rises in the form of lava. But when there's a convergent boundary, what happens underground is that when you grind those two plates next to each other for such a long time, that generates enough heat to melt the mantle. And then when the mantle melts, you create lava, which rises to the surface. So yet divergent boundaries and convergent boundaries form volcanoes. Transform boundaries usually do not. But that's not all, but again, tectonic plates is not the only way to get a volcano, just like earthquakes. Any other questions? These are great questions, guys. Oops. Who? Oh, Haiti. Yeah, I mean, if you look at this map here, see how this tectonic plate just kind of cuts through the Caribbean. So there, yeah, there's a big earthquake zone there for sure. Yep. Yeah, I mean, there's lots of places in the world that are more prone to earthquakes than others, and just by looking at a map of tectonic plates, it really becomes evident why. So let me show you. Let me just go back and I'll show you your assignments for today. So again, the paraphrase and plate boundaries, those are just two assignments that were from last week. If you guys didn't get to finish, today's your chance to do that. This Pangea cutout, if you don't get to it, that's okay. But if you don't have anything else to do, please work on it. I'm gonna put a hard copy of the paraphrase and Pangea cutout in the center here in case you guys want those papers. So I'll let you start working. If you have any questions, let me know.